Now we are going to discuss about the equations of the circle. We already discussed some interesting facts about the circle, like definition of the circle, parts of the circle, chord and diameter difference, and secant line and tangent line difference, definition of the pi, use of the pi, arc, segment and sector. We also discussed how to calculate the area of the circle. For all this term, you should watch our previous video. Now we move towards the equation of the circle. First of all, what is circle? Circle is a set of points whose distance from a fixed point is a fixed distance. Circle on a graph. Now in this lecture we discuss circle on the graph, equation of the circle, standard form of the equation, general form of the equation of the circle, and from general to standard form of the circle. We consider a radius of 5 lengths. Here we consider a radius of 5 length and xy be the any points on the circle and the center at the origin 0 0. Now let's work out exactly where all the points are. We make a right angle triangle. What is right angle triangle? Right angle triangle is a type of a triangle in which one angle is 90. In this right angle triangle, we can see that 5 is the hypotenuse of the triangle, y is the perpendicular of the triangle, and x is the base of the triangle. And this x1 be any arbitrary point on the circle. There are infinite many points possible on the circle. We consider only one arbitrary point of the circle. As we know that in the right angle triangle, the Pythagoras theorem satisfies. Statement of the Pythagoras theorem is here. In this case, we are going to take the C as a hypotenuse, A as a perpendicular, and B as the base. And what Pythagoras says about the right angle triangle says that the hypotenuse square is equal to perpendicular square plus base square. Okay, where A is the perpendicular and B is the base and C is the hypotenuse. Now we apply this theorem to our triangle. As by seeing the labeling, we can see that C5 is equal to hypotenuse, y is the perpendicular and x is the base. So we have x square plus y square is equal to 5 square. Hence we know that 5 is the radius of the circle. Now we consider some more points for these discussions. We consider these points on the boundary of the circle and try to find the equations of the circle. First of all, we consider a point 5 0. We know that its x coordinate is 5 and its y coordinate is 0. Then by taking their square and sum, we have 25. You can verify that. Next point is 3, 4. It means its x coordinate is 3 and y coordinate is 4. By taking its square and sum, we again get 25. Now we move towards the next point, that is 0, 5. Its x coordinate is 0 and y coordinate is 5. And by taking its square and sum, we again get 25. You can verify all these points. Now our next point is -4, -3. That means its x coordinate is -4 and its y coordinate is -3. And by taking its square and sum, we again have 25. Now we're going to discuss our last points. 0, -5. X coordinate is 0 and y coordinate is -5. And by taking its square and sum, we again have a 25. What we conclude from all these informations? The result is, in all the cases, the circles follow the rule that the x square plus y square is equal to the radius square. You can check all these equations satisfies this rule that x square plus y square is equal to radius square. As we vary the values of x and y, again we get the same result equal to radius square, where radius is the 5 and 5 square is 25. Okay. Here is an example for the equation of the circle where the x coordinate is given as 2 and the radius is given 5. We have to find the y coordinate by using this relationship that x square plus y square is equal to r square. By putting the values and simplifications, after taking the square root, we have the value 4.58. Okay, with positive and negative sign. It means we have 2 points, two values, two possible values of the y. One is positive 4.58 and second is negative 4.58. We can draw this graph where center is the origin 0, 0 and x coordinate is 2 for these 2 points and y coordinate is 4.5558 and minus 4.58. As we know that y coordinate y is negative in the fourth quadrant, that's why we consider these points in the fourth quadrant, and x is positive in first and fourth quadrant, that's why 2 is here. These 2 points we consider. Okay, next one, more general case when we consider center at AB. Okay, here we consider center at some other point rather than origin, that is AB, and xy be the any points on the circle and r be the radius of the circle. So the circle all points xy are r distance away from the AB. Okay, as we know that the radius of the circle is r, so all points xy on the boundary of the circle are r distance away from the center AB. Now let's work out where the points are. Now we again using the Pythagoras theorem for the equations of the circle or standard form of the equations. First of all, we understand this diagram's labeling. We consider a point xy on the boundary of the circle and the center is AB. And we know that this is the origin and its coordinate is 0, 0. AB points is x. If we can see that distance from origin to this point AB is A on x-axis, and from origin to on y-axis distance is B. Now we have to find the values from A to the circle. Okay, this one is A in x coordinate and this point is x in x coordinate. By taking its difference we have x minus A. Similarly, for y coordinates we can see that on y coordinate from origin to AB we have y distance, and from origin to this point we have y distance, and from origin to AB we have B distance on the y-axis. Okay, by using these terms again we use a Pythagoras theorem and we have the values. Here hypotenuse is r, base is x minus a, and perpendicular is y minus a. By taking the square of x minus a plus y minus b, we have r square. Example of the circle. But you may see a circle equation and not know it. Here we can consider an example because it may not be the neat standard form. Okay, as we see from the previous slides, the standard form of the circle is x minus a plus y minus b whole square is equal to c square. Now we consider an example where a is equal to 1 and b is equal to 2 and c is 3 radius. Okay, by putting these three terms we have x minus 1 square y minus 2 square is equal to 3 square, that is the radius. By taking their square using the formula of x square x minus y whole square, that is equal to x square plus y square minus 2xy. We have this equation. By looking on this equation, it is not clear that this is the equation of the circle, as the standard form of the circle is this one. So what we can say about this equation? General form of a circle. Basically, this is the general form of the circle. So when you see something like that, in fact you can write it the general form as a constant instead of the numbers. We can put the constants instead of the numbers as a coefficient of x and y, and the constant term. Coefficient of x we consider a, and the coefficient of y b, and the constant term is c. We can write this as a general form of the equation. By expanding the squares of the standard form, we get this general form. Note that in the general form, x square plus y square are the two terms of the equation, or the first two terms of the equations. Now imagine we have the equation in general form and we have to convert it to the standard form. This is the general form of the equation. How we can get into standard form like this? X minus a square plus x minus b whole square is equal to r square. The answer is to complete the square. Read about that twice, once for x and once for y. We have to complete the square for both, for x and y, both terms. General form to standard form. Here we consider an example in which we convert from general form to the standard form. The general form of the equation is given here: x square plus y square minus 2x minus 4y minus 4. Okay, put x and y's together in this expression. Now we have to complete the square. We already discussed details about the completing square in our video related to quadratic equations. We complete the square and then we get the term. For completing square, we have to add minus 1 whole square to the both sides for completing the square of this term, x square minus 2x. We add minus 1 whole square on the both sides, and for completing the square of y square minus 4y, we have to add minus 2 square on the both sides. Then we get these terms: x square minus 2x plus 1 and y square minus 4y plus 4 is equal to 9. We can write as x square minus 2x plus 1 is equal to x minus 1 whole square, and similarly we can write that y square minus 4y plus 4 is equal to y minus 2 whole square is equal to 3 square, as 9 is equal to 3 square. So now we convert completely a general form of the equation to the standard form of the equation. Here we can see that a1 and 2 are the center of the circle and 3 is the radius of the circle. Thanks for watching. Hopefully this video helps you to understand the concept of the equation of the circle and relationship between the standard and general form of the equation.